And so all of this happened within 1 second of launch. And because we lost one of those engines, the vehicle essentially burned off and lost some of that mass of the propellant and did that cool hover maneuver until it achieved a sufficient thrust to weight ratio to actually lift off. And so the changes that we've made primarily focus on that propellant loading system. And so we've relocated and changed how that system it onboards the propellant onto the rocket to make sure that in the unlikely event that anything should leak, it will be much less likely to mix and cause a similar situation. And more broadly, we looked at how we tested and verified that system and implemented some changes into how we do our component testing and verification more broadly to help prevent these kinds of issues from happening in the future. And I just want to commend the team for working really, really hard. We're talking combing through data by the millisecond and working very, very hard over the course of just a matter of weeks to complete this work and get us back to the pad really quickly.
Absolutely, and it is still worth mentioning, though, that this is actually the second Rocket 3.3, because there's kind of two different naming schemes to talk about. There's the version of the rocket, which even though this LV7 is different from LV6, they're both in the 3.3 classification. Can you tell me what the difference between those two schemes are?
Sure. So kind of like a software release version, Rocket 3.3 is like the overall release. We constantly intend to be iterating and making small changes to the vehicle, but those kind of the 3.3 number is really like the class of this rocket, and so there were really substantial changes between the Rocket 3.2 launch in December and this current Rocket 3.3 vehicle, but in essence we expect the changes from tail number to tail number of this rocket to be pretty similar, and so we'll just continue to refer to them by their tail number without really changing that class or release number.
Gotcha.
Until we get to sort of our next major iteration of the vehicle.
Gotcha. And so this is the 7th launch vehicle, but the second of Rocket 3.3, that version. And this is Astra's 4th overall orbital launch attempt, again, aiming to demonstrate that orbital capability before moving into customer flights. In the meantime, we have just hit that T-minus 30-minute mark, and as we said, we're expecting them to hold there. So we're in this hold. The teams are currently working to just complete propellant load operations, and once this hold is released, we'll have a new target T0 time and an actual target time for liftoff. So we'll bring that to you as soon as we have it, as the teams continue to work it. In the meantime, we're going to keep the Q&A going here, and again, if you have questions, please tag us at NASA Spaceflight in chat. And my first question comes from Tin Man that says, how tall is the rocket and what propellant does it use?
So we will definitely be talking a lot about the specs of our vehicle, but overall our vehicle is 43 feet long from tip to tail, so it fits pretty snugly in a 45-foot shipping container, which helps makes our logistics and transport to the site pretty easy. And as far as the propellants, both stages use a combination of liquid oxygen and RPX, which is essentially kerosene. And so both our first stage powered by the Delphin engines and our upper stage powered by the Ether engine use those propellants.
And to differentiate, because there are a few rockets that use kerosene and liquid oxygen, it's a pretty common mixture of Falcon 9, Atlas 5, to name a few. But those actually usually use an RP1 kerosene, and you're just saying RPX, so that's just a different grade than maybe the other companies use?
Yeah, that's right. It's slightly different from RP1, but we use RPX.
Gotcha. Next question from chat that says, at T-minus 2 minutes and counting, does the flight computer take over the countdown? Where does that occur?
Yeah, so one of my I think most exciting moments of the countdown is hearing it's at T-minus 60 seconds. The call from our flight director will be that the vehicle is on internal control. And at that point, at T-minus 60 seconds, that's when the internal systems are now in command of the vehicle, and they'll continue to command the vehicle through flight. So there's no human input into the system during a nominal flight, where our guidance algorithms are and our flight software algorithms are in control of our rocket.
And as we get farther into the countdown, we'll definitely highlight and explain some of those things as they happen, as of course that's a later in the countdown issue. But we're going to keep them coming here. Next question from chat says, will there be any other versions of this rocket?
Well, certainly for tonight, we are focused on the launch of LV0007. And as we mentioned a little earlier, our goal is to reach daily space delivery and offer a rocket launch every day. So Astra has many future plans. You can learn more about them by following us on Twitter or checking out our website, astra.com. And as a public company, we also provide a lot of future information in our SEC filings. But for tonight, we'll be focused on LV0007 and our mission to reach orbit.
All right. Speaking of reaching orbit, I got a question here from Avenger asking, why fly from Kodiak when it is harder to reach orbit because it's so far away from the equator?
Yeah, that's a wonderful question. So first of all, I just want to shout out our wonderful partners at the Pacific Spaceport Complex, Alaska, and we really enjoy working with them. I'm very glad to have launched out of there, and we'll continue to launch out of Kodiak in the future. Really, the choice of the launch site is partially determined by the mission. So tonight's mission for the Space Force is heading to an inclination of 86 degrees, which is a favorable location to reach from Kodiak. Kodiak is great for reaching polar and high inclination orbits, which are common for Earth observation missions. And otherwise, launching from the equator is typically very common because that's where Earth's rotation is the fastest. So you get a boost that helps rockets reach orbit. But there are many different reasons for selecting a launch site, and in this case, launching from Kodiak is actually very favorable for the mission.
Yeah, from the physics perspective, you can actually say that when you're launching to a near polar orbit, a high inclination orbit like this mission, it actually hurts you to be close to the equator because you don't want that velocity. So before getting too much into orbital mechanics, I don't want to make this a physics lecture or anything, but it's all about what orbit you're going to, and it's very interesting.
That's right. I think just to quickly highlight a few other things that are great about launching out of Kodiak is it's a little hard to see right now, but during the daytime you would see, we have a beautiful view, and this launch pad is right on the ocean. So launching over the water makes it obviously easy to keep away from populated areas. We work with the Coast Guard and FAA to make sure that there's no boats or planes in the vicinity and ensure safety is our top priority. But the location near the water is also makes Kodiak a great choice for launches.
Yeah, you can't see the ocean in this particular camera view, but you can see the lack of lights around the launch complex, which means there's nothing else out there. You got plenty of room to yourself. There's a map of the actual launch trajectory, like the hazard zones that go around the planned trajectory for this launch. So you can see flying south from Alaska towards a near polar orbit, and you got all that room and all that ocean out there to make sure that the launch is conducted safely. And that's, of course, very common for launch sites. Most launch sites can launch over water or over uninhabited desert. That is the safest way to ensure that falling stages or any mishaps during launch do not affect public safety, and that's very common. The next question, are there any advantages to launching at night?
So the choice of our launch window is really determined by working with the FAA and make sure that we're minimizing the impact to air travel and marine traffic. So due to Kodiak's proximity to Anchorage, Alaska, which is a very, very busy airport, and our upcoming busy holiday season for shipping, the night window was determined to be the option that we had for this mission. Some other reasons for the choice of a launch window may be due to the specific objectives of the satellite, or the precise orbit where the payload is seeking relative to the position of other satellites already in orbit, and of course being able to avoid.
Hello. Hi. So today Astra is going to be attempting to launch their Rocket 3 to 69.7 degree inclination orbit. It's a polar orbit. That is why they are launching from Kodiak, as it is easier to get into polar orbits than equatorial orbits.
Seat.
Gotcha.
So I am just gonna turn on their stream until the hold is released, and then I will start talking again.
To show you, we actually have a little bit more from our NSF factory tour to show out some bits about how they weld this rocket together and some cool manufacturing stuff. So let's look at that really quick.
So this is what we call our circumferential TIG welder. Essentially what happens on this machine is we'll bring a dome in here, we'll chuck up a dome, and we'll add a barrel section. And this machine is automated. You basically tell it which weld you're running. It positions everything for you, lights the torch, and it'll zip a weld all the way around the circumference. And we just keep adding barrels until we close out and add domes. We basically just grow a first stage tank on this machine.
Okay. And I know the stages on Rocket 3 and going forward are going to be being stretched a little bit, right? Mm-hmm. Are there changes to the barrel sections and the domes that need to have to that, or is it simple as let's just add more barrel sections?
From a high level, basically it's as simple as add more barrel sections. We had package protected for a longer rocket with extra rails on this machine in particular. And there's a limit to how much you can do there because you need to start optimizing around buckling stability of your tanks and what pressure you operate the tanks at, and you end up with a bunch of different trades as you change the aspect ratio of the rocket and the skin thickness and whatnot. So, but we package protected early on enough that was not a difficult change for us to accommodate.
Gotcha.
So our tanks use two different weld processes. We do friction stir welding for longitudinal seams that go up the raceway or the raceway axis, and then we use TIG for the circumferential seam. So if you're up on your pressure vessel math, you'll know that hoop stress is exactly double the axial stress of a cylindrical pressure vessel. So you need double the weld performance on that linear seam.
Right.
So we use a friction stir weld there that has really high weld performance, greater than 80% paramaterial strength coming out of that weld. And then we use a TIG weld for where we don't need it, which is roughly 50% paramaterial strength, right, order of magnitude.
And are there benefits to doing that and just not doing friction stir welding everywhere?
Yeah, friction stir weld is actually super complicated to do circumferentially. It's actually quite simple to do linearly, right? So we do friction stir welding where it's easy and simple, and then we do TIG welding where we don't need the complicated process. So we do that TIG on the circumferential seam because it's a very, very well-developed process, super easy. We don't need any reaction anvils on the inside of the friction stir welder. No crazy stuff going on here, just pretty simple methods.
Gotcha.
So we have one of our values here at Astra is simple scales.
Right.
So we try to choose the simple way to problem solve. For me, if you're solving a problem and it looks complicated, you should be asking yourself a question of, am I solving the wrong problem? And can I look at this in another way that actually makes the answer simple? It's a common thing that you're taught when you're going through engineering school, that there are many ways to go about answering problems, and some are much simpler fundamentally than others if you take the right approach. So we definitely try to choose wisely when we're going to apply the right technique.
Okay.
Again, super cool to get a tour of the factory here at Astra, and if you want the full version of that, please check it out on NASA Spaceflight's YouTube channel. In the meantime, we're still in that T-minus 30-minute hold, but I've got a new guest here. Chloe Song is an embedded software engineer here at Astra. Chloe, thanks so much for taking some time to join me today.
Yeah, thank you so much for having me. It's a really exciting time to be here.
Absolutely. You're just going to talk about what is your job and your responsibilities here at Astra as an embedded software engineer?
Yeah, so like you mentioned, I'm an embedded software engineer on the avionics software team. And our responsibilities are to develop and test the flight software that go on the rocket. So things like our guidance computer, our GPS, our radios, anything with a microcontroller on it, really, we're developing that code. And another big part of what we do is to test that and validate the software changes that we make. So we have what we call a hardware-in-the-loop simulator, our Mock-it. And that's really cool because it contains all of the avionics, our harnessing, a lot of sensor simulation, GPS simulation, all that. So it basically acts like a rocket that's flying. So anytime we do make a software change, we can then validate that and run like a full mission simulation and make sure that the expected outcome does actually happen and we can catch any bugs in the software.
Wow, that's very extensive. That's a lot of stuff there. What part of that is your favorite part of what you're doing here at Astra?
Um, well, I mean, it's the cool thing about Astra is that no matter what you work on or touch, right, it's either going to go on the rocket or it's going to help us launch. So you really have an opportunity to make such a big impact here, and as an engineer, that's always really exciting to me. So yeah, I think just knowing that, you know, I'm writing software for the rocket and it's gonna fly, I mean, that's really cool.
That is really cool. The whole Astra motto here is around, simplify to scale and things like that. How does that philosophy apply to avionics and electronics design?
Right. So our simplify to scale philosophy is really about balancing quality, overhead, and scalability. And so when we're designing hardware or software, we have to constantly think about, okay, what's the simplest version of this that we can deliver to get us to our result in the quickest way possible, but also allow us to go back and add features and iterate on that in an easy way. So with printed circuit boards, for example, where you place a connector on a PCB can actually affect what the enclosure design looks like. And the enclosure design can affect how the sub-assemblies team is putting stuff together. And even down to like integration when we're putting something on the rocket, if something's like really difficult to put on there, you know, that can be a big time sink for us. So any time savings with manufacturing and installation that we can make, we're constantly thinking about that.
Interesting. And that must be really involved with the testing process too and iterating from that perspective. What does that testing process look like for the electronics?
Right. So we sort of go through two test processes. One is qualification, and the second is acceptance testing.
Right.
So the first is qualification testing, and when you have a new design, you have to verify that that's going to survive a launch, right? You can't just put a board on the rocket and expect it to, you know, go through all that vibration and thermal cycling and work. So we actually have a lot of that test equipment in-house. So we do vibration testing, thermal testing. We have a thermal vacuum chamber that we use, and that gives us confidence that our products will survive a launch. And so after that, once you have a qualified design, you go into acceptance testing and production. So when we do get a batch of circuit boards back, we can't just put that on the rocket either. You sort of have to verify and do like a baseline functional testing and make sure that, you know, you're measuring the right voltages, your communication buses are all working at full speed, things like that. And that's sort of the last gate before delivering a flight-ready unit to the rocket.
Gotcha. And then I always like to ask about the human side of things. We talked a lot about hardware and software, of course, with the avionics team, but the human element is something that I think is really exciting to just learn about here at Astra. You got a lot of different backgrounds and things. What kind of roles make up the avionics team here?
Yeah, we have a bunch of roles. There are more embedded software engineers like myself. We have an awesome group of electrical engineers, GNC engineers who are basically celebrities after the last launch. But we're also hiring. We're hiring for experienced RF engineers, antenna engineers, avionics electronics technicians. So I would encourage anyone who is listening or viewing our live stream to go to astra.com/careers and see what's out there, whether or not anything I mentioned is relevant or not. I think we have over 100 job postings on the website now. So we are definitely ramping up hiring.
Every time we come here, the number of employees keeps increasing. So, you know, they're definitely growing, and that's super cool to learn about and hear about. So, Chloe, thank you so much for taking some time to do some question and Q&A with us, and good luck with the launch tonight.
Thank you so much. Thank you for having me.
In the meantime, we're still in this hold at T-minus 30 minutes. Again, teams are working on completing propellant load operations. We'll have more information and hopefully a new T0 before too long, and we'll share that as soon as we have it. In the meantime, let's go ahead and listen into the countdown net and the microphones out at the pad as we wait for this hold to clear. And welcome back again. We're still in this T-minus 30-minute hold. The teams are still working that. Of course, they're working it on backroom nets and stuff, so the countdown net's actually been pretty quiet. We got those microphones out of the pad, but no countdown chat, right? Countdown net chatter, geez, right now. But we're going to dive back into Q&A. So again, if you've got questions about the launch, please tag us with that in SS Placer. We're going to keep those going here. The next question from chat, from Steven, asking, could you explain the process of preparing the rocket for another launch after a scrub?
Sure. So last night after our scrub, we first removed detanked all of the propellants from the vehicle. We bring the vehicle down. That's one of the first steps in our countdown procedure, is to lift the vehicle vertical. So we bring the vehicle down. We conduct any inspections. We review any items that came up during the launch attempt. So again, in the case of last night's scrub, the issue with the igniter system, came up with a mitigation plan for that, and implement that fix, and get a good night's sleep and go again.
The sleep is very important, of course. Next question from chat. Ernest asking why the launch suppression, the water system, sprays away from the rocket during launch.
Yeah, so what's most visible is the outward plume, but we actually do also have part of the system that sprays in towards the system. During the water deluge, we mostly want to make sure that we don't get any fire or anything on the ground. We don't want to get water into our systems immediately in the seconds before launch. But in the event that there is a fire in the launcher, we do have a portion of that system that is directed directly at the launcher as well.
Got it. Next question from Tara, saying, does Astra have any dedicated launch photographers? Definitely my dream job right there. Sorry, that was from Josh, so thank you, Josh. I believe I can actually take that one, because a couple of friends that you may have heard of on NASA Spaceflight broadcast before have done some photography with Astra. Our good friends John Krause, our good friend Brady Keniston. If you're familiar with NSF's coverage, you've seen their names before. We've seen them out there in Kodiak, so some familiar faces and some familiar names with the launch photography here. Next question, Zach is asking, is there a flight termination system on the rocket?
Yeah, so we do have a flight termination system on the rocket. We'll go through our mission control operators, and one of those folks, Lucas Hundley, is our flight safety system operator, and making sure that if in the event that the vehicle is going off course, we can make sure that there's no bad outcome. So that is, we do have a flight termination system on the vehicle. In our case, it commands the first stage engines to shut down the vehicle and end the flight.
And that's different because some FTS systems are more destructive. They actually terminate the rocket by blowing it up, basically, versus thrust termination.
Right. So because our vehicle is so small, we don't need to use that more explosive system. We can instead command the vehicle to shut down the engines, and we ensure that this is done within our trajectory, within our safe zone. So there should be, everything should be clear in the event that the flight needs to end early.
Yeah. Next question from chat. Question, how much time does it take to roll out the rocket and set up on the launch pad?
Yeah, so we can set up a launch pad in a number of days. We ship, this is a great view of our launch pad. You can see one of the shipping containers sort of near the bottom of your screen. But pretty much everything that you see in front of you, except for the large tent and the fence and some of the fixed infrastructure there, does fit in standard shipping containers and goes over trucks and boats and occasionally even aircraft to make it to the launch site. And our red team was a team of a handful of folks that that accompany the rocket and the ground support equipment to our launch site. Will set up the launch pad in a matter of days.
Next question, let's see. What things do you need to take with you to the launch pad? So, relevant question there.
Yeah, great related question. So we bring pretty much everything that you see with us. We bring, of course, the rocket, the launcher that you see, which is the black launch mount sitting underneath the rocket, and the long arm, that's the strong back. We bring those with us. We also bring containers which help us pump the propellant through the system, and we bring pretty much everything we need. So we pride ourselves on having a fully mobile system, and really all we need at a launch site is a concrete pad and an internet connection, and we can set up a spaceport.
Very cool. Next question here. How high will the orbit be tonight? So what orbit are we targeting tonight?
Yeah, maybe we can talk a little bit more generally about the mission objectives, but we are heading for an orbit of 500 kilometers and an inclination of 86 degrees. The payload we have on board LV0007 is a mass simulator for the United States Spaceports, and that camera view will show
What's in the fairing?
these lights will light up as we send a signal to simulate payload deployment. Again, because the payload is a mass simulator, we will not actually be deploying it. And this is the
think
United
that's
States
inside the
Space Force
fairing.
second mission, STP 2782, which is intended to demonstrate Astra's ability to deliver for the Department of Defense.
Gotcha. And this is more or less a kind of a redo of the previous launch attempt too, just aiming to demonstrate that orbital capability with a mass simulator on board.
Right, that's right. Our main goal tonight is to reach orbit.
Gotcha. Next question. Let's see. How visible will the Aurora be during stage separation? Maybe talking about the rocket exhaust there, or maybe Aurora? I don't know. What do you think?
I don't know, but that's a wonderful question, and I personally think it would be really cool to see the Aurora during tonight's flight. I can tell you, and with our 3.2 launch in December of 2020, we were all so focused on seeing that beautiful ignition of the upper stage engine and watching those milestones that I don't think we would have noticed the Aurora.
Sure.
But it might make for a cool view tonight. We'll just have to wait and see.
And speaking of the cool views, I've got another question, Chad, and I'm going to tee up Michael Baylor for this one. Will there be any cameras on board the rocket for this launch? I think we caught a glimpse of one with the fairing earlier. Right now we've got a bit of a fogged out view from one of the first stage cameras looking down the side of the rocket, but there they are, hopefully looking to come back to those views once the rocket is flying through the air, hopefully later tonight. There's one from the upper stage. That's the upper stage still sitting in that payload fairing, and that's a little bit different for Astra's rocket, right? That stage actually sits in the payload fairing with the payload.
That's right. A large portion of the upper stage is encapsulated by the fairing.
And there's another view. Oh, that's looking down the second stage, right? That's like the second stage, bottom of the tank and the nozzle, right?
Oh yeah, I think I see that it's kind of a dark curve shape in the middle. That would be the nozzle extension of our upper stage ether engine.
Shout out to Mr. Michael Baylor showing off the onboard camera views there. The next question in chat: what fuel does the second stage use, and what engine?
Yeah, so both of our stages use the same propellants, which is liquid oxygen and RPX, which is essentially kerosene. And our second stage engine that we were just talking about is, we call it Ether. It's designed and built and tested all in-house, just like our first stage engines. The Ether engine produces 740 pounds of thrust, and it is a pressure-fed engine. So our first stage engines are electric pump-fed engines. Ether is a pressure-fed engine.
The next question here asking, what does their flight software testing process look like?
Sure. Well, I think Chloe, our embedded software engineer, talked a little bit about the testing process during her interview, but I'll just recap some of the things that we do. We have a simulator that we call the Mocket that we use for a lot of our simulations.
Great name, by the way.
Yes, it's a pretty good one. So the Mocket, it's pretty cool. It's all of our avionics and our harnesses and everything sort of laid out to really simulate all of our systems in a pretty robust way. And we're constantly testing and updating things. We do a lot of automated testing, and we are of course, getting the latest wind information during our countdown, and we run simulations and incorporate that data into our latest and greatest flight trajectory immediately before launch as well.
Gotcha. Another question from Chad. Again, if you have questions, please tag us with that NASA Spaceflight and keep bringing those in. We're going to keep asking them. And the next one asking, what is Astra's current production rate?
Sure. This was actually a similar question that we had from the Alameda Boys and Girls Club yesterday about how long it takes us to manufacture the rocket. So we just want to shout out to the kids at the Boys and Girls Club down the street from our headquarters here in Alameda. And right now it takes us a few months to build each vehicle, and you know, we're gradually ramping up and working towards that goal of delivering a rocket every single day. Of course, it may not necessarily mean we build a rocket in a day, but have the capacity to deliver a completed launch vehicle on a daily basis in the future. So we use, this is some of the ways that we stand out from the competition, I think, is using simple materials, using tried and true processes, using as much automation as we can in our systems, to simplify and really stand out as working towards building to scale.
Gotcha. Again, if you're just joining us, we are still in a T-minus 30-minute hold right now. The teams are currently working through finishing propellant loading operations, but I think we can take that opportunity to actually look at the different roles in mission control. Here is actually a view of mission control here in Alameda, California. And Carolina, can you talk us through who we're looking at and what all their jobs are?
Yes. So we will start with Chris Hoffman, who is our flight director. He is responsible for overseeing and directing launch vehicle operations per the countdown manual, with the authority to call hold, recycle, or abort as required. And as a fun fact, Chris Hoffman also runs Rocket Cat Rescue on the side. So if you're looking to help some kitties in need, check that out. To his left, with the Google eyes on his console, is Thomas Arand, who's our Flight Activities Officer, or FAO, and so he's responsible for documenting all of our operations as they happen and making a note of any future after items that need to occur after the fact. Continuing clockwise, we have Chris May, who is Command and Data Handling, or CDH, and he monitors and adjusts state machines as needed under command from the flight director. Then Joshua Green is our vehicle controller with the call sign of Tango, so you'll hear a lot of him as we listen into the countdown net. He operates the terminal controlling the vehicle systems under the direction of the flight director. Then Dan Wilson, GNC and trajectory, or the call sign GNC. He ensures weather and wind trajectory information is up to date, properly loaded, and meets flight criteria, and also wears really great sweaters.
He also has the joystick on his desk, which is, of course, very important.
Yes, the very important joystick that doesn't actually do anything, but is very important. And then Lucas Hunley, flight safety, or call sign FTS. So he's responsible for making sure that the vehicle is on the trajectory and calling the flight safety system should it not be following its planned path.
Gotcha. And so those are most of the call signs that we'll hear on the countdown now, though there are also a few others, right?
That's right. So our mission control, as you can see, is a very small group of folks, but you may hear other call signs as we got into the go and no-go polls, and those are our what we call the engineering back room, which are the engineers who are responsible for the different systems on the rocket. So ACE is our ground software system, INCO is our radio system, Odin is flight software, Delphin is our first stage engine, Ether is our upper stage engine, Booster is the first stage system, Orbit is the upper stage system, Launcher is in charge of the ground support equipment, and Panther is the backroom coordinator. So you may hear those call signs as we continue to listen to the countdown, and you'll hear those during the go, no-go poll as well.
And on top of all of those folks who are working here in Alameda, we also got the skeleton crew that's out there in Alaska, and we mentioned them earlier about the Red Team doing their work. Can you talk a little bit about what the heck the Red Team is?
Yes, our huge shout out to Red Team, who is out there in these cold conditions, making sure that our vehicle and systems are go for flight. So starting off with our Red Lead is Adam Frisch, who is responsible for all the activities and the safety of launch pad related operations. Then we have a few pad technicians who are Hill Hudson, Robert Freeman, Eric Larson, and Sam Hirschap. They operate the hardware hands-on on the ground before the remote systems take over, so they're the ones who are making sure that everything's set up. We have our IT, or Red Wire, who's Eric Steinberg. We call him Steiny.
Yeah.
And so he's the specialist in our IT systems and AV, and we have to be very thankful to him for the great broadcast that we're having this evening as well. And finally, our safety lead is Ryan Hirschfeld, who's responsible for the safety of overall launch operation events, including personal compliance with our safety policies and procedures, which is really important. So again, want to give a huge shout out to our red team who are out there in the cold and dark. We are very grateful for the hard work that you do.
Absolutely. A very cool team out there, and it's cool to see them work. In the meantime, those teams are still working a hold. We're at T-minus 30 minutes and holding. Propellant loading is just finishing up still, and the teams are working on that. As soon as we have a new T0, I will share that with you as soon as we can. But in the meantime, let's go ahead and listen into the pad mics as the rocket sits there and gets fueled up, and we'll bring you some more information as soon as we have it. And again, we are still holding at T-minus 30 minutes and holding. However, we are getting close to resuming that count. And once we have the firm new T0, we'll go ahead and share that with you. We'll do a little bit more Q&A, but once the countdown resumes, the countdown is going to get pretty chatty, and we'll go ahead and listen into that because that's always cool. But again, getting close to resuming the hold. Once we have a new T0, I'll share that. In the meantime, let's go ahead and do some more Q&A here. The next one, let's see. How does fuel get into the rocket?
Sure. So you see that the fuel is pumped into the rocket through our launcher system and the ground support equipment that goes with it. So you may be able to see some of the long hoses on the ground. You can see that this black sort of support structure that the rocket is sitting on, that's our launcher, and it's actually a really complex piece of equipment. You can also see the lines that connect the upper stage to the strong back, that long arm that is leaned back, and so that is those are some of the lines that pump the propellants into the vehicle.
Next question here. Let's see. Shannon in chat says, we're all familiar with the wildlife that Florida fondly calls KSC security. There are gators out there, of course. What sorts of wild visitors do you get in Kodiak?
Yeah, so there certainly are bears out there. I don't think we've seen any recently, but I think the red team in the past has seen plenty of deer and moose and things like that. And during this launch campaign, there's been a friendly little fox that has been roaming around as well, which has been a nice thing to see. But of course, we work with the range and make sure that things are as clear as possible and as safe as possible before we begin our launch operations.
The next question from chat says, what is the latest time, that Astra can launch in today's launch window?
Sure. So we do have about 2.5 hours remaining in our window. Our window closes at midnight Pacific time, so we actually have plenty of time in our window remaining for launch tonight.
Yeah, and again, if you're just joining us, we're still at T-minus 30 minutes and holding, and we're waiting for a new T0, but hopefully getting close to that information being with us here. The next question from chat, though, in the meantime, Kenny asks, is Astra going to deorbit the payload?
Right. So today's flight is a test mission. So the payload that we have is actually just a mass simulator. So it will not be deployed during this mission. So there will not be any need to deorbit it. The first stage will deorbit, will burn up in the atmosphere with the payload attached to it. We will be sending a signal to simulate the deployment and make sure that everything would have worked nominally had we had a non-mass simulator payload aboard the rocket today.
So just to clarify, the upper stage and the payload still attached will both destructively re-enter safely and mitigate, no space debris and things like that.
Right, exactly. Okay. We consider that to be very important. We want to be responsible stewards of space, and our mission is to improve life on Earth from space, and one of the ways that we think is important to do that is by making sure that we use space responsibly and aren't creating a bunch of space debris.
Gotcha. Absolutely. The next question from Quinn asking, will Astra ever have a need for civil engineers?
Astra has needs for all kinds of engineers. I think that's one of the most exciting things about working here, and one of the things that makes us unique is we have folks from all sorts of different backgrounds, and we have a lot of obviously specialists in aerospace engineering and propulsion, but many of our team come from automotive backgrounds, from different startups and companies around the Bay Area where we're located. I myself have a biomedical engineering background, so you can check out our careers page on astra.com and see the types of opportunities we are hiring for. But we like to have a diverse set of backgrounds because it helps us build rockets differently.
All right. A related question here in chat. What's the difference between the machine shop, the production team, and the engineering team?
Sure, that's a great question. So the engineering team, they are the team that is really working on the design of the vehicle, and designing all of the components. The production team is responsible for building the rocket and taking those designs and making them into a reality. And then we have an in-house machine shop, which is sort of part of our production team. And a lot of what you see on our vehicle and on our launch system does come into our factory as raw material, as sheets of metal, and our in-house machine shop turns them into the finished product that you see today. And all of these teams work very closely together. We're all trying to build for scale from the outset, and so it's very important for our engineering team to consider, how are we going to make not just one of this part, but how are we going to make tens and hundreds of this part so that we can scale up our production.
The next question from Jet says, can a manual abort be issued when it is under 10 seconds from liftoff?
Yeah, so an abort can be called at any point in the countdown, and so I've mentioned earlier that the vehicle's is on its internal control in those final seconds leading up to launch, but an abort can be called at any point, and the system can also use its own sensors and checks to abort immediately before launch. So there's always a way to hold off and to stop the process as well.
Gotcha. Again, if you have any questions about the launch, what you're seeing, what we're talking about, please go ahead and throw those in the chat. And if you tag us with @NASA Spaceflight, we'll be able to see them, and we'll bring them in, and we're going to keep asking those over the course of the broadcast. We are still waiting for this hold to clear, hopefully getting there soon. We're at T-minus 30 minutes in holding. Once that hold is released, we should have a new T0 for you, the targeted liftoff time, and as soon as we have that, we'll share it. But in the meantime, teams are still holding, and we'll have a new T0. Like Carolina said, the launch window extends another hour and a half or so. I'm sorry, 2.5 hours. I can't do math in my head. My apologies. 2.5 hours.
Yes, we have quite some time remaining.
The next question from Sam says, how will Astra manage countdowns and launch? Sorry, let me rephrase that. Okay, we're just getting word. Sorry, getting interrupted because we have new news. We're getting ready to resume the countdown. A new T0 on the way, 0534 UTC. So it looks like we should resume the count in just about a minute. Let's go ahead and listen into the countdown, Ed, as that occurs.
This is flight on countdown. Astra is resuming count at this time. Per step 106, FTS verify mission data load values are ready to be loaded onto the AFTU. Run CAS software as required.
CAS software is running. AFTU is green.
Safety, confirm that you have all Astra employees and guests in Kodiak accounted for.
Safety can confirm.
And all personnel are in a safe location?
Correct, you have 2 individuals at AMC.
GNC, verify for me we are still green on COLAs with a 6:04 time, and still green on blackout avoidance.
Confirmed, green on colas and blackout avoidance.
RCO, flight on countdown. At this time, Astra requests power on transmitter and enable tone A.
This is RCO, that's in work. Flight, this is RCO. We have carrier up and monitor up.
Copy that. Safety, verify signal strength and good power up.
Safety can confirm.
Tango and AV1 rocket support cart, please enable the FTS.
FTS is enabled.
Safety, verify FTS is enabled and nominal.
Safety can confirm.
RCO, flight on countdown. At this time, Astra FTS is enabled on the vehicle.
RCO copies.
This takes us to final software load. Tango and machine pump battery 2, manage pump battery charging. Please set us to mode 2, stop charging pump batteries.
Mode 2, charging is stopped.
In AV1, manage power systems, toggle off guidance power system authority.
Guidance power system authority off.
In AV1 managed polling, toggle do only ground polling.
Do only ground polling. On.
Per step 120, Tango, are you ready to load new late load configs?
Standing by for late loads.
Go ahead, Delphin.
Igniter controller config is 154 Victor 1.
GC igniter 154 Victor 1. Good load.
Engine alpha is 155 Victor 18.
Engine alpha 155 Victor 18. Good load.
Engine bravo is 156 Victor 15.
Engine bravo 156 Victor 15. Good load.
Engine charlie is 157 Victor 15.
Engine Charlie 157 Victor 15. Good load.
Engine delta is 158 Victor 18.
Engine Delta 158 Victor 18. Good load.
And engine echo is 159 Victor 16.
Engine Echo 159 Victor 16. Good load.
Ether, please provide your late load config.
Ether late load config 163 Victor 11.
Ether controller 163 Victor 11. Successful load.
GNC, please provide your late load config.
We're loading 5 Victor 137 L4 configuration.
5 Victor 137. GNC Kodiak launch config. Successful load.
Alright, Tango in VB1 turn on off PDBs, please run a GNC setup.
GNC setup on.
Okay, so I think they are at the time we're a little over 25 minutes until liftoff. So scheduled liftoff. Liftoff would currently be set for around 1:03 at exactly 1:03 a.m. Eastern time.
And again, as you have seen, they're working through some engine configs because we are back into the countdown. T-minus 25 minutes or so and counting. Our new T0 is 10:04 p.m. Pacific time or 6:04 a.m. UTC. And the countdown is proceeding. Carolina, what are we doing right now in the countdown?
Sure. So the next step in the countdown is we're going to spin up the pumps of the first stage engine. It's one of our final checks, and we're well on our way to our T0 time in just 24 minutes.
And we're going to keep listening into the countdown net as those milestones get hit. You can hear the mission controllers and the backroom engineers working through all the final preparations for launch, so we'll listen into that. We might have a little bit of time for Q&A, so if you have more questions, please throw them in the chat. We might come back to those in a little bit, but right now let's focus in on the countdown as it progresses. Again, new teaser of 10:04 p.m. Pacific time, 6:04 UTC.
By the way, that large cloud, all those clouds you're seeing is normal, since they use really cold propellant and the air is warmer than negative 200 something degrees. It condenses and turns into condensation, and they have to vent it off to keep constant pressure while they're loading it. So that is just what those clouds are. And you'll also notice that some ice forms along the side of the vehicle.
And the countdown net's been a little quiet, but the teams are still progressing through their milestones. And of course, every time I keep saying let's go to countdown, they get quiet. It happens sometimes. But we're at T-minus 23 minutes and counting, and everything proceeding nominally right now. Let's go back into some questions here. And Sam in chat asked, how will Astra manage countdowns and launch schedules with daily launches? It seems like small delays could hold up many launches.
That is a fantastic question, and I very much look forward to having those problems. Those will be good problems to have. But we're focusing tonight on our launch of LV 0007, and so you can keep your eyes posted on our future plans by following us on Twitter and checking out our website astra.com, where we'll be sharing more information about our future plans.
All right. Next question, what are some of the metrics that Astra is expecting to gather from this flight?
Yeah, we get data from all different aspects of our system. Some of the things that we look for is, the health of our launcher, of our ground systems. We also get a ton of data from really every part of the rocket that we're looking to verify, tons and tons of data that our engineering teams will then review after the flight and will use to learn and iterate and make improvements to the vehicle. But the most important objective that we're hoping to achieve tonight is reaching orbit, and again simulating that signal for payload deployment for the mass simulator that is our payload for this evening's mission.
Speaking of payload, I got a question in chat from Brody asking if the white area on top is a larger fairing or just the very tip. Can you just tell us what we're looking at right now? Because there's tanks, there's frosty tanks, and there's the white part up top. What are all these different components?
Sure, and maybe we can bring up. We have a graphic to show the different parts of the vehicle that we can maybe bring up, but. Bottom of the first stage, and then we'll work our way up the rocket. So first you can see we have our first stage Delphin engines. Those are electric pump-fed engines that each produce 6,500 pounds of thrust. You can see sort of 3 of them peeking out from under the engine bay, but we do have 5 of them on the first stage. And then they are attached to that engine bay segment, which contains the pumps, the electronics, and the plumbing needed to run those engines. Moving up to the right is the first stage, that is the largest segment of the vehicle, and that is the propellant that powers those Delphin engines. Both stages are full of liquid oxygen and RPX, which is essentially kerosene. And then the kind of cone-shaped section, that's the inner stage. That contains a lot of the avionics of the vehicle, and also is where the nozzle extension of the upper stage ether engine sort of fits in snugly. And then looking to the right, the upper stage, that sort of dark triangle shape, that's the bottom portion of the upper stage ether engine, which produces 740 pounds of thrust. It's a pressure-fed engine, and there is one of those on the upper stage, and you can see the two spherical tanks on the upper stage that are, again, liquid oxygen and RPX with that payload adapter plate on top. And then finally, the 2 halves that you see above and below the upper stage, those are the fairings, which are in 2 halves, which come apart in order to install that payload on top of the upper stage.
And so those are all the different components, and then when it gets all fueled up, we have this extra kind of confusing bit because it gets frosty near the top of the first stage, and that's the liquid oxygen tank, right?
Right, that's right. So you can see, now if we go from the top, you can see the fairing is kind of that curved upper portion that has the that triangle sticker, that's the Space Force logo, and then the portion that has the star, the Astra logo, that's the inner stage, that cone-shaped portion, and then the part that has kind of what, the steam and the ice on it, that's the top portion of the first stage. So you can see that the first stage is really the majority of the length of the rocket.
And of course, the top portions are the only painted versions. We got that nice bare aluminum down the side of the first stage engine, which of course gets covered up in frost. You might not even be able to tell once it's fully fueled. But the reason that not the whole first stage is like this, because only the liquid oxygen gets cold enough to condense the air around it. The kerosene's at ambient temperatures, right?
Yes, that's right. So the liquid oxygen is very, very cold, and what you're seeing is that ice forming on the outside, kind of similar to the condensation forming if you're having a very cold drink on a hot day. So that's the ambient air around it condensing and forming a thin layer of ice that does tend to fall off as the rocket proceeds through its trajectory.
And then what are all these vapors that we're seeing? We're seeing some around the rocket and also a bunch from the ground equipment around the rocket. What's that?
Yeah, so those are vents to make sure that we're keeping the propellants at the appropriate temperatures, pressures, making sure that everything remains nice and full, and then the sort of steam that you may see coming off the rocket, that's just kind of that condensation on the outside of the rocket.
We are coming up at the point of the countdown at T-minus 17 minutes and counting here. We're coming up on the water test. We'll see the groundwater deluge test. Now it should be pretty visible. So let's go ahead and listen into the countdown net and listen into the pad as that test comes underway.
Oh, there it is. There's some of the water. I don't know if it'll do the big fountains, but there's really big
Tango,
fountains.
close water valve 100.
Water valve 100 closed.
Water valve 104 closed, please.
104 closed.
Thank you. Good water test. GNC also confirms good on winds.
Or not, they'll just do those.
And as you just saw, we had that water deluge test, so the team's continuing to work through the countdown, and everything appears nominal for an on-time liftoff. Again, the T0 is currently targeted for 10:04 p.m. Pacific time. That's just over 16 minutes from now, and we're now getting close to entering the terminal count, I believe is our next milestone, right, Carolina?
That's right. So that's at our T-minus 15-minute mark is terminal count, which is really our final checks of the vehicle, and we can listen in. We'll have a go no go poll very shortly to proceed into tank pressurization and launch.
Let's go ahead and listen back into the countdown as the Astra teams get into terminal count.
GNC self-test. GNC call out upon completion with result.
GNC self-test started.
Self-test is passed.
Copy. FTS, confirm that the FTS is still enabled and nominal on the vehicle.
The FTS is enabled and nominal.
Tango in fuel for operate, please toggle full.
Fuel for operate, full.
And
on.
fast.
Fast, on.
Please let me know when you're ready to inspect the launch machine and set a new UTC T0 time.
In work. Good to set time.
Tango, I'd like you to set a new UTC T0 time of hours 6.
Hours 6.
Minutes 4.
Minutes 4.
Seconds 0.
Seconds 0.
Please save and commit.
Changes committed.
All right, we are into the terminal count now. Less than 14 minutes to go. Let's give a brief overview of what today's launch will look like, Carolina.
Sure. A few seconds before liftoff, we will light the 5 first-stage Dolphin engines, and the system will run checks to make sure that everything is nominal. If that looks good, at T0 seconds, we will release the hold-down release mechanisms for liftoff. A few seconds later, the vehicle will begin its pitch over to continue its trajectory. And after that, the next objective is max Q at 1 minute and 10 seconds after launch, a very significant objective. That is the point of maximum aerodynamic pressure on the vehicle. 2 minutes and 50 seconds into the flight, we'll have main engine cutoff, or MECO, and then a few things happen in pretty quick succession. The fairings will separate, and then 5 seconds later, the first stage and the upper stage will separate from each other, and the upper stage ether engine will light at 3 minutes and 5 seconds. It will run for a little over 5 minutes until we have second engine cutoff, or SECO, at 8 minutes and 30 seconds. And then at 8 minutes and 40 seconds, we will have the payload deployment signal. Again, we have a mass simulator as our payload on this mission. We will not be deploying it, but we will send that signal to simulate our deployment. And if we will have achieved all of those steps, we will reach orbit, and we will be very happy with the outcome of this evening's test flight.
Absolutely. Fingers crossed for a very successful test flight. And just over 12 minutes from now, we're going to listen back into the countdown net. They're going through the final steps preceding the go, no-go poll for tonight. And of course, if all systems are polled go, we are into the business end of the countdown. So let's listen in. 12 minutes and counting.
Active.
AV1 managed power systems.
Active.
All flight helium machines.
Helium stack is up.
VB1 first stage power.
First stage power active.
VB1 upper stage power.
Active.
VB1 turn on off PDBs.
Active.
Water 1 water system.
Water 1 water system active.
This time, Tango, I'd like you to activate launch machine.
Launch machine active.
Please toggle lock stopping.
Lock stopping set to true.
Okay, per step 150, this takes us into the hold for tank pressurization and launch. After this point, any system issue must be called as a 3-word hold. If there are no concerns for flight, call go, otherwise call no go. Red lead.
Red lead is go.
FTS.
Go.
Delphin.
Go.
Ether.
Ethers go.
Odin.
Odin's go.
Inco.
Inco's go.
Ace.
Go.
Launcher.
Launchers go.
Orbit.
Orbit is go.
Booster.
Go.
GNC.
GNC is go.
FAO.
Go.
CDH.
CDH is go.
Tango.
Tango's go.
Safety.
Safety is go.
Flight is go. Tango and AV1 manage polling. Please toggle do only ground polling.
AV1 manage polling. Do only ground polling. On.
Delphin, are you ready to load sequences?
Delphin's ready.
Tango, are you ready?
Tango is standing by.
Go ahead, Delphin.
Igniter sequence is 703 Victor 3.
Igniter sequence 703 Victor 3 slot 0. Good load.
Engine Alpha is 821 Victor 3.
Engine Alpha 821 Victor 3 slot 0. Loaded.
Engine Bravo is 822 Victor 2.
Engine Bravo 822 Victor 2 slot 0. Good load.
Engine Charlie is 823 Victor 2.
Engine Charlie 823 Victor 2 slot 0. Loaded.
Engine Delta is 824 Victor 2.
Engine Delta 824 Victor 2 slot 0. Good load.
And Engine Echo is 825 Victor 2.
Engine Echo 825 Victor 2 slot 0. Loaded. Successful load.
Astra's gonna call a hold right now.
RCO copies, we have a hold.
No. They called the hold.
As you see, we're at 8 minutes and 38 seconds and holding now. A hold has been called, Carolina.
Yeah, as you can see, there appears to be a valve stuck open near the base of the vehicle. It's one of our ground side valves that the team is working to cycle and get that fixed. If we do resolve the issue quickly, which we hopefully will be able to resolve, then we would recycle the clock at T-minus 15 minutes with a new T0 time. So we'll provide some updates as soon as we have more information. But again, we are in a hold.
Yes, are in a hold, and we will also share a new T0 as soon as we have that information as well. So standing by. All right, we are still in a hold. However, those teams have been able to cycle that valve that we were looking at, and it sounds like we're going to be ready to recycle back to that T-minus 15 point, the terminal count point, and we'll have a new T0 here shortly.
Yes, that's right. The teams were able to resolve the issue. You don't see any of the sort of cloud that was forming near the base of the vehicle, and we believe we have addressed the issue. So we'll have an updated T0 shortly.
And again, once we get back into terminal count, the next big milestone is going to be, after a couple preliminary steps, there will be the go, no-go poll once again to get back into the final 10 minutes of the count. But they're going to recycle to the hold point of T-minus 15 minutes to actually enter the terminal count. And once we have a new T0, we'll share that.
Yeah, because you could see the vent purging, and then you could see it stop, and that was the vent that they were talking about, the ground support vent, and that under the erector or the stand is the main vent that you would see venting from. So you could see it purging by turning on and off, and they got it to close. So soon they should recycle to T-minus 15 minutes.
Alright, we are still in that hold, but we are expecting a new T0 shortly. The teams have been able to cycle that valve that we were seeing in the bottom of the launcher there, and we're expecting a new T0 shortly.
Yes, that's right. The teams have resolved the issue, so any moment now we expect to have an updated T0 and resume the countdown.
What we'll hear on the countdown net, which we'll be able to listen into, is them setting that new T0 time, and then the teams will go back into go, no-go polling to proceed with the launch attempt. So standing by for that T0 call from Flight Director Chris Hoffman.
Flight on countdown picking back up. Tango, please let me know when you can deactivate and inspect the launch machine to update our T0.
In work, deactivating launch machine. Inspecting, ready to set a T0.
Hours 6.
Hours 6.
Minutes 16.
Minutes 16.
Seconds 00.
Seconds 00.
Save and commit.
Changes committed.
Then let me know when you're ready to activate.
Ready to activate.
And as you just heard, our new T0 is 10:16 p.m. Pacific time, or 6:16 UTC. The Astra teams are now 9 minutes and 30 seconds left.
That's good.
Go. Red lead.
Go.
FTS.
FTS is go.
Delphin.
Go.
Ether.
Go.
Odin.
Go.
Inco.
Inco's go.
Ace.
Go.
Launcher.
Launchers go.
Orbit.
Go.
Booster.
Go.
GNC.
Go.
FAO.
Go.
CDH.
CDH is go.
Tango.
Tango's go.
Safety.
Safety is go.
Flight is go. Tango, confirm that in AV1 managed polling, we are still in ground mode.
We are currently in do both ground and guidance, turning only ground pulling on. Do only ground is set to true.
Delphin, do you require new sequences?
Sequences have not changed, so we do not need to reload.
Copy. Ether, please provide me with your flight sequence for tonight.
Ether flight sequence 806 Victor 3.
Ether sequence 806, Victor 3. Title all hosses, no bosses. Slot 0, loading.
You just heard the teams have polled go for launch. We're at T-minus 8 minutes and counting.
Tango and AV1 managed polling, please toggle do both ground and guidance.
Do both ground and guidance set to true.
Delphin, please confirm GSE igniter system is ready for launch.
Igniter system is ready for launch.
FTS, issue logic on AFTU, verify CAS is green and nominal.
And work. Logic enable issued and received on both AFTUs.
Copy.
Seven minutes until their targeted liftoff of 1:15 Eastern time.
Tango, at this time verify that the vehicle is ready for launch aside from tank pressures.
Blue lines are met, looks good.
If you're just joining us, we're at 6.5 minutes and counting. Everything on track for a liftoff at 10:16 p.m. Pacific time. Teams have pulled go for launch and are now into the final steps of the countdown.
RCO flight on countdown. At this time I am looking for final range green and launch authorization for this evening.
This is RCO. Range is green. You are authorized to launch.
Thank you.
And you just heard the range has authorized go
So
for
the
launch,
is
range
go.
green.
The range is clear, so there's no boats, no planes, no people in the area of the launch.
Tango, at this time in the launch machine, I would like you to enable launch.
Launch enabled.
Five minutes.
Now T-minus 5 minutes and counting. Again, everything on track and nominal for liftoff.
RCO flight on countdown, verify range, will be recording telemetry at liftoff.
This is RCO. I can confirm range is recording telemetry.
Thank you.
4 minutes.
4 minutes. Reminder to control room, if you require RF data, please be prepared to switch over your Grafana pages at liftoff. FSO flight on countdown. Please be prepared to issue option command at T+162, calling out at event.
Roger, 162.
Coming up on 3 minutes and counting. Again, we are 3 minutes away from liftoff.
3 minutes. They're so close.
3
This is
minutes.
Astra's 4th orbital launch attempt for LV, and this is LV 0007 into the business end of the countdown. Let's listen in for the final steps and liftoff.
Reminder to all that any 3-word hold from here on out is an immediate abort regardless of source. Tango, please turn off igniter heaters.
Igniter heaters coming off.
Okay, so that means if there is any
Good
hold in the
current response.
countdown, they will abort for the night, which means they will cancel any launch opportunities for the night, and they will have to go with their next launch window, which I think is
FTS,
tomorrow.
you are good to send master enable and watchdog on AFTU.
And mark.
Minutes.
2 minutes.
Master enable and watchdog sent and received on both AFTUs.
Copy.
Let's just hope it doesn't go sideways this time.
T-minus 145, all systems nominal at this time.
Seconds.
During
So
launch, we'll have
close.
live telemetry
Ace,
on the
at this
bottom
time
right
you
of your
can
screen.
start PSD recordings
Done.
and start downrange recording.
Also done.
60 seconds, vehicle's on internal control. First stage LOX tank pressurizing. First stage
40
fuel
seconds.
tank pressing.
And tanks are not pressing for flight. They're pressing the flight levels.
30 seconds.
They're so close.
20.
15.
15. Water
10
on.
seconds.
10.
There's the water suppression
9.
system.
8. 7. 6. 5. 4. 3. 2. 1. 0.
First motion.
Running. First motion. Vehicle is clear of the tower.
LV0007 has cleared the pad and is on its way to space. Our next objective is Max Q. On the left side of your screen, you'll see the progress of the vehicle through our mission milestones, and you can see velocity and altitude.
LV0007 ascending through some clouds over Kodiak, now looking at onboard views from the rocket.
That was a beautiful liftoff.
Vehicle's just passed 50 meters per second, 3 kilometers in altitude.
Vehicle's tracking downrange.
There, so it's
And the
getting
vehicle's
its
just
pitch
started pitching
downrange.
downrange.
It didn't go sideways, it went up. 1 minute.
T
of
plus
flight.
1 minute. The vehicle is now through maximum aerodynamic pressure, the point of maximum aerodynamic stress on the vehicle. Next up is main engine cutoff, or MECO, at just about T plus 2 minutes and 30 seconds.
So
Vehicle now over 300 meters per second at an altitude of 12 kilometers.
soon you'll start seeing some plume expansion. The higher you get in the
And
atmosphere,
everything appears to be nominal at this time.
the less air pressure there is, the more the plume can open up and expand. You're seeing that right now. It's just opening and opening up.
Vehicle's on track downrange.
It's
We're
looking good.
confirming that the vehicle is on track downrange and all systems appear nominal, nearly at the end of our first stage flight.
And you can see as the rocket ascends to the thinner parts of the atmosphere, you can see the engine plume expanding. That's a gorgeous shot from that onboard camera.
Two minutes. See, look, it's like really opened up now because
And
they're
now
getting
we're coming
really
up on
high.
main engine cutoff just about 20 seconds from now.
This is looking really good. This is way better than last time already.
Good signal strength. Vehicle's tracking downrange.
There should be MECO. Where is it gonna cut off?
Option set.
What?
Confirmed. Option as received.
So the plume is now at like full expansion at this point. They're past the carbon line. There's MECO.
And we've just heard the
MECO.
call out for main engine cutoff.
There's stage separation.
There we
fairing.
have fairing separation
There's stage
and a
separation.
successful stage separation.
Look at those gorgeous onboard views.
And
We
that
have ignition of the upper stage ether engine. T plus 3 minutes, 22 seconds and counting. The upper stage now taking control of the flight. Teams are here in Alameda very excited, and rightfully so. 3.5 minutes in the flight, everything on track so far. Again, this burn lasts just over 5 minutes. We would expect second engine cutoff at T plus 8 minutes and 30 seconds. And this second stage's job is to get the payload and itself all the way up to orbital velocity.
we're looking for the altitude of 500 kilometers for this mission.
currently passing 200 kilometers already into space, but of course you got to get that extra velocity and altitude to stay in orbit. That's the big ticket. But again, everything nominal at this time.
Looking at our mission control team, still holding on to the controls, and here we have the crew of folks at Astra who are very happy with the outcome of today's flight so far, and we are still holding on for that second engine cutoff.
Everything continues to be nominal. T plus 5 minutes now. Vehicle now over 300 kilometers in altitude, 4.5 kilometers per second of speed.
And we want to give a shout out as well at this point to Thibault Lassalle for our graphics this evening. We are very happy to see our mission progressing with the graphics that we have, and continuing to watch that beautiful sight of the first stage, or excuse me, the upper stage ether engine taking us to orbit.
You see that actually engine bell glowing from the heat of the rocket operating, and of course the little bit of plume in the night sky south of Kodiak. Again, this mission going to an 86-degree inclination, so a nearly polar orbit, flying pretty much straight south from Kodiak. T plus 6 minutes, about 2.5 minutes left in this upper stage burn, and everything on track so far.
So we've got a little bit over 2 minutes remaining in this upper stage flight. We're just at 400 kilometers, which again we're getting we're now less than 100 kilometers for our target orbit.
Vehicle now traveling 5.5 kilometers every second and an altitude of 434 kilometers. Again, that live telemetry is in the bottom right hand of your screen. And on the left, you're seeing the different milestones. We're into second stage flight at T plus 7 minutes, about 1.5 minutes left to go.
So you can see the second stage.
Again, there is no deployed payload on board the upper stage, so as long as this second stage burn completes successfully, there will be a simulated deployment signal, and then that's it. The main objective is to reach orbit, and we're just over a minute away from that happening. And T plus 7 minutes 30 seconds, all on track. A big shout out to the teams here in Alameda watching closely.
Engine pressure still looking good.
T plus 8 minutes in the flight, all systems nominal. Second stage burn coming to a close here shortly.
Cut off.
Pico.
And there you have it, orbital insertion, second engine cutoff, and Astra's LV0007 has successfully reached orbit. There is a new orbital rocket. And there is the view of the simulated payload, the mass simulator up top. Mission success. Just a 9-minute trip to orbit, and Astra is in orbit.
And I can speak for the team. Everyone is hugging and cheering here. We are absolutely bursting with pride at LV0007, lucky number 7. This represents a huge, huge step in our mission to improve life on Earth from space.
Astra's 4th orbital launch attempt, LV0007, the first one to achieve orbit, a successful test flight and demonstration, paving the way for future customer missions. Very exciting to see here. Absolutely gorgeous views all the way. And a very happy team here in Alameda. I'm sure a very happy team up in Kodiak as well. There is your flight path right down the middle.
I want to say to everyone who's joined us, thank you so much for sticking with us. And again, to confirm, we have accomplished our main objective for today. LV0007 has reached orbit with its test payload. I'm so proud of our incredible milestone for Astra and all of our partners, a major step forward in our mission. And we will continue to provide innovative, low-cost, and nimble launch capabilities riding on this evening's success.
From the NASA spaceflight team, this is Thomas Burkhardt, News Director. I just want to say a big thank you to Astra for trusting NASA spaceflight with this broadcast, being able to see firsthand the first successful orbital launch of a new company's rocket is just something incredible. It's incredible to be here with the teams. Just from our perspective, this is just so cool to experience, and a huge congratulations, Carolina, to you and the entire Astra team on this accomplishment. It is no small feat. And of course, the iterative path to orbit, it took, you learned a whole lot on the way there. But this has just been so cool to watch. Thank you so much for partnering with us to do this.
Thank you so much, Thomas. Let's go celebrate.
All right, everyone, thank you so much for watching. This has been super cool. Again.
So, thank you for watching. Please like, subscribe, and I will see you guys next time.
Tom's with us really quick.
Hey guys, how's it going?
It's going well. Of course, Chris Kemp, CEO of Astra. Chris, congratulations to you and the team. How are you feeling right now?
Absolutely incredible. The team's worked so hard on this for so many years, and this just really seeing iteration after iteration, failure after failure lead to success. Everyone is just incredibly passionate about corks are flying. Yeah, I mean, it's an incredibly hard thing to do. Continuing to do it is incredibly hard. We have rocket serial number 8, 9, 10 in production, so we're just getting started.
Absolutely. Chris, thank you so much for allowing us to be involved in this, and best of luck going forward, and go celebrate.
Indeed. Thank you, guys. Bye.
Again, everyone, thank you so much for joining us. Carolina, Chris, the entire Astra team, the entire NASA spaceflight team, and most of all, everyone watching at home, thanks for tuning in. Big thank you to Astra and partnering with us to help make this broadcast happen. Couldn't have done it without you. And NASA spaceflight and Astra, looking forward to future Astra launches. Stay tuned for future spaceflight coverage on NASA spaceflight with this mission